All right, welcome back. We are doing something a little different today. We're on episode 9 now. We are going to be doing or implementing our controller. So we're going to be implementing like an abstract controller that can function in our game. Currently we're just kind of doing raw key presses to implement movement, but we want to put that into its own abstract class so that maybe in the future we can add different sort of supports, different keyboard supports, etc., etc. There's also the possibility of changing keys out. So we're going to create the abstract implementation for that, as well as we're going to use a new callback function, which you guessed it, key callback, where we monitor our keyboard, and then when a key press actually ends up happening, update our game with that. So without further ado, turn off the old camera. And let's start by creating our controller component. Why not? So let's go ahead and call this component controller. There we go. And then in our component controller, we'll probably need our component class, component E. And we're going to be storing all of our keys into our game as like a static variable. So we'll also include game.h. And let's actually create that static variable. Why not? Let's go to game.h, and we're going to have a static. It's going to be array of booleans. Let's see if I defined anywhere. It looks like I do right here. It's going to be an array. We'll just use the standard array here. And we could just use the C style. It's really inconsequential, but whatever. And then how many keys do we want? Let's put a lot. So let's do 1024, as that is 2 to the power 6, I believe. It's a nice function that the computer likes to handle, so we'll just use that big number there. And we'll call this keys. And then we got to implement that in our game.cpp here. So we'll do standard array of bool and 1024 the size. And we'll use game.keys. And then we'll set everything to 0. I guess we'll do that. Game has no member keys. I believe it does. Maybe include array. Maybe that's what's causing the error there. Looks like that was it. Perfect. All right, now let's actually implement our controller class. So we'll do class. Actually, let's do namespace first. So class, controller, public, iComponent. That's what it's called here. And then let's go ahead and implement the virtual functions. So it will be virtual. Let's do key down left, and we're gonna have I think 4 main keys for movement. So that's down, right, left, right, and then we'll also have some action keys. If you want to fire or you want to talk to an NPC, and then we will have start or as a pause, and then maybe select. Who knows? I don't think any game ever uses select, so we probably won't use it either. But let's start off by just implementing our movement keys for now, and then we'll implement the actionable keys at another point when we actually have to deal with actionable keys. So We're just doing key down events. This is very similar to like what you find in like JavaScript. It's just when the key is pressed down, we want to like return true. Now, if this is different from like a key press, so a key press would be up and then down, or sorry, down and then up. That would be a key press, and we will implement that at another point as well. That's going to be very important for like actionable events. So now we have our component controller. Let's go ahead and create, let's add a filter. This is going to be our controller filter. So it's going to have our component controller, and then let's go create a component class that implements our controller. We're going to call that a keyboard controller. So component controller keyboard. So this is going to include component controller, and then we have a bunch of nasty namespaces here. Namespace component, namespace controller. And then we'll have our class keyboard. And that's public component controller. I actually don't know if this is going to throw something. I think it will. So let's call this iController since it is an interface. Rename that there. And let's continue here. We are going to, let's see, we'll need some key IDs. So I guess we'll just hard code our keys for now. That kind of defeats the purpose of the intro that I was talking about. But yeah, I mean, eventually this will all go into like JSON files, but we're not even there yet. We're not even close to JSON. So we're straight hard coding stuff for now. So let's call this enum key ID, and we'll just have left. And then I guess we'll probably need glfw. So let's go ahead and include that as well. And we'll call that glfw key. And I'm just going to use the arrow keys since they're really easy. I mean, obviously you can use like WASW or WASD. And other options. I don't know, whatever you feel like using, you can use. It's not really a big deal. So we got key down, key up. Let's rename these. This is down. This is up, and we got right. So now let's implement our virtual functions. We're not going to have anything in our constructor, so we can just kind of leave that. I guess we could define it. Our deconstructor is already defined in component, so we don't really have to redefine that here. Then let's go bool key down left. Actually, I think we include game in controller, but we don't want to include game in controller. We want to include it into keyboard. Oh, whoops. It wasn't that. Oh, there we go. Key down left, and this is a pretty simple function. We're just going to be returning game keys and then inputting left here as it is lined up with our keyboard that it's getting updated through our key callback function that we'll define later. Let's do key down right. I should have just copied and pasted this entire thing, but oh well. right. And we'll do the, oh, got an extra one there. So this is going to be up, and this is going to be down. So pretty much what we're doing here is, these are just like simple functions that are interfaceable. So that means that like in polymorphism, hopefully you have some sort of background in computer science before following along with this tutorial. But we're just setting up just like these interfaceable key options so that we can pretty much like call a controller, and then it will always like input like whatever is down, right, left. If it's coming from the keyboard, if it's coming from like a game controller that you set up, etc., etc. So there we go. This is our full implementation for our keyboard controller. Let's go ahead and now see if we can implement it. So let's go to our main. We'll need to include it. So let's actually include that first. Component controller keyboard. I'll just delete this, as that is not true. We are not on episode 5. We're a little bit farther along than that. Let's include it with player. In the future, I guess we could just include it to game, because it's going to be accessible by all game states, our controller class, and then we can replace that controller with a different one if need be. But luckily with our system, that kind of handles itself. So let's just go ahead and just add. Let's add it after our shader stuff. So our texture and shader stuff, and after our renderer. Why not? Auto and controller. We'll call this C keyboard or C controller. We'll just call it CC keyboard. That seems good. And then game, add ID component. Whoops. And then component controller keyboard. Let's call this controller for now. And we don't actually have to implement anything into it, because we're just hard coding things for now. So that's good. That should work out just fine. I guess we should create a system that updates our movement. So we might as well create another system while we're at it. So let's just add that here. We could do key callbacks first, but I'd rather just do everything at once, because this is not really runnable until we get a system together as well. So let's create this system, call this move. Why not? So component system update, and let's just call this move. Need to get component system.h. Let's actually just copy and paste our camera file here. So we do a little bit less work. Also, we could zoom in a bit more here. Don't need this anymore. Well, we just don't need that in general. The only components we'll need is transform and component controller, or iController. And let's just call this transform. And we'll also need a variable that keeps track of our speed. So let's just create that here. So we can implement that. So it's very similar to what we were doing in our main file. In fact, it's a carbon copy fact, we could probably just copy and paste a lot of this here. Except we'll be replacing the GLFW get key with window, and we don't have to implement window into our component system. That can be completely left out. We just update our transforms by the speed that we implemented. So just copy paste that there. This is still transform. Let's get rid of some of this red here. Component rectangle. And include component controller. So controller. And let's also implement our float speed into our constructor here. So this is controller. This is transform. And then our speed. So if controller dot key down up, we want to decrement our transform by our speed variable in the y direction. And then similarly, and then the same deal for down, left, and right. We want to do that as well. So this is down. And this, I think, is right. And this is left. All right, so now we have our move function. Well, it's called camera. So let's actually rename this here to move. So now we have our move function all completed. We can now include it into our main class and check to see what our effort actually ended up working out. We've been having a lot of errors recently, so there's no there's no telling if it's going to run or not at this point. I believe it will, though. This was a pretty simple change to our project here. It wasn't like that expansive in terms of what we needed to do. Let's see here. Yeah, let's add it to our player class. So auto CSU component system update. And this is our player. It's going to be move. So e player add ID component system update, and you got move, and we'll just call this move. And then all we need, I think it's transform. So C PLA transform, and then we need the C keyboard for the keyboard that we're updating to, and then lastly the speed, which what do we set our speed to? I guess we have it defined, so let's just copy and paste that over into our move function. So we no longer need this process input. We can actually just go ahead and delete this now. We do need to add our move to our update systems. So let's just copy and paste this here. CSU claw move. So now we have movement being updated every single frame. Let's go ahead and make our key callback. So currently everything's all working, but we just don't, we aren't updating our keyboard. So to do that, we're going to create a new callback. We're going to call it key callback. I'm just going to copy and paste that. So this is what GLFW needs to define a key callback here. So it's like scan code, key, window, action, mode, or what have you. So we'll go ahead and create that at the bottom here. We can delete process input. That is deprecated. So inside of our key callback, so if, we'll just have a giant if statement. If key is outside of the range of 1024, we want to not do a key callback because our array only goes up to 1024. And key is less than 1024. This should honestly be defined as a const expression, and after this video I'll probably do that since I did not do it already. Then if action, so the action is just if it's down or up pretty much for most keys. There can be more complicated actions for like a joystick that will give you like ranges or what have you, but we're not, these are key callbacks, these are not joystick callbacks, so they're just up and down. So GLFW press, I believe, is the action that we're looking for. We want to update our global game of keys to be true. So key, not lay, key is equal to true. And then else, if action equals GLFW release game keys at the key position is equal to false. So there you go. Really simple key callback sort of function here. Now we just have to go to where we set up our callbacks. So GLFW set key callback, I believe. There we go. Set key callback window, and our callback function, which, what do we call it? Key callback, of course. Couldn't have called it a better name. All right, there we have it. I think everything is all taken care of. I guess there's only one way to find out, and that is to just dry run our program and hope for the best here. And it looks like we have something popping up, so that's good. At least there's nothing going wrong with that. Now let's go ahead and see if we can move. And would you look at that? We can. So you notice there's like a little bit of, when you move, it doesn't update the camera immediately. We can actually change that. If you like that, you can just keep it. But that's just a problem of our ordering of, update systems. So if we want to remove that to make it act like it did before, we just move our play move before, oh wait, not that one. This one. So when we push it back into our systems, we want to make sure it's before our camera. And we can actually do that in a later bit. I'll eventually update systems. It's not just going to be an array or a vector. It's going to be its like own thing. But yeah, so that's how you fix that if you were curious. So notice the camera updates after you move the the sprite or the character. So now he just kind of still floats. I think I said we were going to do animations today, but I didn't look at my notes, and it seems like we're doing controller. But yeah, that was fun. That was good stuff. Thank you guys so much for watching. I hope to see you in the next episode. Goodbye.